Hello friends, today I'm going to solve LeetCode problem number 23, merge k sorted lists. So in this problem we are given k linked lists in an array of lists, and each of these linked lists are sorted in ascending order. Now what we need to do is we need to merge all of these linked lists into a single sorted linked list and return that linked list. So we are given this example here. Let's look at this example and see how we could solve this problem. So what are we given is three linked lists in an array of lists. All of these three linked lists are sorted. So we have 1, 4, 5 in the first linked list. The second one is 1, 3, 4, and the third one is 2, 6. Now we need to merge these three linked lists into one linked list. So how we could solve this problem? How could we perform the merge? So when you need to perform a merge, we could merge the first two into one linked list and then merge this linked list with the next linked list and keep continuing with the other linked list if there are more linked lists here in this problem. So that is what we are going to do. So what we do is, since there are only three linked lists, so we merge the first two linked lists. So the first two linked lists given us are 1, 4, 5, 1, 3, 4. So how are we actually going to perform the merge? Well, I have created a solution already for this problem, that is how we could merge two linked lists into one sorted linked list, but I'm still going to explain it to you here, but I will explain it in very brief. If you want to look at the detailed video, I'll put the link down in the description so you can go and look at the detailed solution description of how you could merge two linked lists. So what we do here actually is, to merge these two linked lists, we compare the first two values. So right now the head is pointing to the first element, so we compare the these values at the head position, and since both of them are equal, but we'll take the first element here and then we'll merge it into our new array. So that will be the first element in our linked list. In the next, now we move our head to the next value. So now we compare the value 4 with the value at the head of this linked list, so which is 1. So we know that 1 is less than 4, so 1 is the next value at this linked list. Basically I am creating an array here. Okay, so linked list 1, and then it would point to 1, that is this value, and then now our head shifts here. So now our head for these two are at 4 and at 3, and we know 3 is less than 4, so the next value that comes after 1 is equals to 3. Then the next value, that our pointer for this one head shifts to this value, and now we compare these to 4. So since both of them are equals, we just take this value and then the next of 3 is equals to 4, and now our head shifts here. So now we have value 5 and 4, and we know 4 is the least, so we add 4 to our linked list and our head shifts to the null pointer, because we know in every linked list the end is at null. So since there is no value here null, so we just return this, the head of this linked list. So the next would be equals to 5. So we found a sorted linked list here, and now what we do is we use this sorted linked list, and then the linked list that we have, this one is also sorted, and now we sort these two linked lists. So we follow the same method. So our head is in the beginning of both of these. Now we start from the first value and then we compare the first value. The first value is equals to 1, and now the next is again here for this one. So now again still 1, so we add the value 1, and now the next is at value 3, and between 3 and 2 is the list, so we add 2 to our linked list, and the next element the header shifts to 6. So now between 6 and 3 is the least one, right? So we add 3 to our linked list, and the head shifts to value 4, and we know 4 is again smaller than 6, so we add the value 4. Now the head shifts to the next element of 4, which is again 4. So between 4 and 6, again 4 is least, right? So we add the value 4, and the pointer shifts to the next value, which is 5. Between 5 and 6, 5 is the least, so we add 5, and now the pointer shifts to the null value here, because we know the end of the linked list always points to null. So now between null and 6, well, null is no value, so what we return is we return the value that this head is pointing to. So we return 6 and add 6 to the next. So now this is our final result. So that is what we are going to do. What we do is if there are n number of linked lists in this lists array, then we are going to iterate over each of the elements. We merge the first two, and then we merge the first the result with the second one, and then we merge it with the next value in the array, and so on. So that is how we are going to solve this problem. So what we'll do is we'll also merge and save the result in our 0th index. So basically we are performing an in place merge, so that we are always comparing our result will be saved in 0th index, that is this place. So we are always comparing this with all the other indices in the linked list. Now let's try to solve our problem using coding, and then let's see. So what we need is, first of all, we need to create a function that would merge two linked lists. So let's create a function merge two lists equals to function, and we'll pass two lists here, and then here we are going to look for the edge cases. If linked list 1 has the value null, then we are going to return linked list 2, else if L2 linked list 2 is null, then we are going to return linked list 1. And now here we are going to check find the list value between linked list 1 and linked list 2. So we are going to compare if the value of linked list 1 is less than value of linked list 2, then linked list 1 would be our next value, right? So L1, and before that we need to also find the next of this. So now we know that this is the next value. So what would be the next value of L1? So now what we do is we perform our recursive call, and then L1 next comma L2 L2, and then we return our L1 from here, and similarly else L2 next equals to L2 next comma L1, and then we return our L2 from here. And what are we going to do next is, now we are going to create our for loop, and iterate over I equals to 1 to I is less than the length of the list array plus plus. We are starting from 1 because we are going to save the value at list 0. List 0 comma lists I. So every time we are going to save our value at list 0. So what we do is initially list 0 and list at index 1. So we pass it, we merge these to 0 and 1, and then the value, merged value, is saved at index 0, and then again we pass index 0 and the value of I incremented by 1, that would be list 2, and so on. And finally what we return is, we return our list at index 0 because we have been saving our merged list at index 0, right? Now let's run our code and look for any errors. Okay, all right, so what we did is we did not look for the base case of the list array, that is, list array could be an empty array without any elements. The length could be equals to 0 here, it's given here, so we have to take care of that. So if length is equals to 0, then we are going to return null. So if list.length is equals to 0, return null. Now let's try to run our code. Awesome, let's submit it. Great, so let's look at the time complexity and space complexity. So here, since we are iterating over each of the linked list, so if the length of list is equals to k, then this would be O of k times, and for the merge linked list we are calling it for each of the elements in the linked list, and this would take O of n time complexity if n is the length of the linked list within the list element. So the total time complexity would be O of n times k, and space complexity is constant.